In this video, we're going to talk about the product rule. What happens is when you're taking derivatives and you have a product, you can't just like derive, and then multiply it all out. You just can't take the derivative of each piece and then multiply it out. So there's a rule actually. When you have multiple pieces multiplied and you're taking the derivative of it, what you do is u is your first, v is your second, just a way to kind of for notation purposes. And all you do is you derive the first piece, the u, leave the second piece, put a plus, leave the first piece, and derive the second piece. That's the basic procedure when there is a product. You do not just take the derivative of each piece and then multiply it. So just be careful about that. All right, so how do we apply this product rule when taking the derivative? Well, here we go. We are going to derive the first and leave the second. All right, so let's just kind of call that u and that v. So if we follow this, we're going to find f prime x, or the derivative of f. So according to that, we derive the first piece. So what do we get there? Well, 3, when you derive this right here, 3 times 2 is 6. Drop the power by 1, 6x squared. This right here would be negative 8. And that right there simply is the derivative of u. This is u prime. Now what's v? Well, it's just sine x. So we're simply going to put sine x. Okay. Now plus. Okay, u. So we just rewrite u. Pretty simple, hopefully. Alright, we're just rewriting u. Sweet. And then we derive v. So what's the derivative of sine x? It is cosine x. And that is v prime. Alright. Now, we could try to simplify this, but technically this is basically the answer. Again, I could distribute all this, and then write it all out really long, but you really don't have to do that. This right here is the derivative in this situation. There are times, and very often, is that once you take this, you want to distribute everything and then combine like terms. But what I notice is if I do distribute these pieces, there's nothing that's going to combine. I just can see that right off the bat. And so it really won't save me any time. All right. So we're not going to worry about going any farther because we're just going to call this the answer. This is our answer. That is the derivative. Again, do not try to derive each piece and then multiply it. Now, here's another option you could have done. You simply could have multiplied the sine x times this and sine x times this and then differentiated. Here's the problem. When the sine x goes to both pieces, don't you have a product rule and you had another product rule? If each of these had sine x next to them, don't you have two sets of product rule? Isn't this thing going to get really long? So you don't want to distribute that. You want to just leave it as is and then go from here. And again, you can distribute and combine like terms if it's possible, but this one does not need it. All right, let's look at another example. G of x. All right, so could we use the product rule here? Yeah. But I look at this and go, well, actually, it might be easier just to FOIL this, get an easy polynomial, and bypass the product rule. You do not need the product rule on this one. Not at all. So what I would do on this particular problem is I probably would multiply this in like that, and then I'd multiply this times that, and do FOIL. So that would give me g of x is equal to 3x times x, which is 3x squared, and then 3x times 5, which is 15x. And then I multiply negative 2x times x, negative 2x, negative 2 times 5, which is negative 10. And there I go. I now have a polynomial, which I can actually simplify to g of x is equal to 3x squared plus 13x minus 10. And then if I differentiate this, I get g prime x is equal to, well, this is going to be what? 6x. And this? Oh, that's 13. There's the derivative. I think that's a lot easier. Now we could come over here, let's just show you, if we did the product rule with this, we derive the first. Okay, this is just, if we use the product rule, we derive that, you get 3x, leave the second, plus, leave the first, and derive the second. Then, if we FOIL all this out, actually, why multiply the 1 in? It's up to you. This becomes 3x plus 15, and this becomes 3x minus 2. What do you notice here? What's 3x plus 3x? 6x. What's 15 minus 2? Plus 13. Same answer. So could I product rule, or could I FOIL and then just do a simple derivative? It's your choice. Now, this one you had to use product rule because if you distributed a sine x, you still got products involved. So you got to kind of learn. Sometimes you just want to do a FOIL and do it. Sometimes you want to just do the product rule. You got to learn your own times that you want to apply it and when you don't want to apply it, and your best way to handle problems, because you don't always have to use the product rule when you have a product. You can simplify it and use other rules. Okay, but product rule will always work when you have the two things multiplied and when you take the derivative in this pattern. Now, one thing you will also realize, some texts, if you run into it, do the product rule in a different fashion. Some text will put like this, they'll derive v first and leave u, and then here they derive u and then leave v. That is just a common way. I don't like that because you're going to learn something in another video called the quotient rule, where this comes to be very useful to keep this pattern. So I like this pattern. But there are different ways to do a lot of things, because basically, does it matter which set is first when you have plus? Does it matter which one you derive first? Don't you just basically derive one of them, leave the other, derive the other, leave the other? Do you see how it doesn't really matter with the plus between? But it's important when we get to another property, when there's something dealing with a minus and other things. So that I like to keep this method. You'll see it maybe in certain scenarios when you get into your derivatives or look at answer keys in different situations. So good luck with the product rule.